Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be continuing our discussion of Section 1 of Chapter 3, Relations and Functions. But this time we're going to focus on finding the domain and range of graphs and then determining if those graphs are or are not functions. So let's take a look at how we're going to do this given some graphs. So picking up where we left off last time, now it's time to start identifying functions using something called the vertical line test. So another way to decide if a relation is a function is to analyze the graph of the relation using the vertical line test. If any vertical line passes through more than one point of the graph, then for some domain value there is more than one range value. So the relation is not a function. So what we have to do, and we're given a graph like in problem 3, part A and B, we have to draw vertical lines on the graph and see if any of those lines cross the graph more than once. So looking at part A, it says, is the relation a function? Use the vertical line test. I'm just going to draw some vertical lines, and I'm making sure it only intersects my graph at least, or at most, one time. Okay, so there one time, that's fine. Here one time, that's fine. Here one time, that's fine. There's not going to be any place where my line's going to intersect the graph more than once. So if this is a function, this is what happens. So we're going to say yes, this is a function, because no vertical line crossed that graph more than one time. So now if we look at part B doing the vertical line test, this graph just has a bunch of different points on it. So I'm just going to draw a vertical line down the points, and I can only hit one point. So that was fine. But this, I just intersected twice. That's not okay. So anytime I draw a vertical line, if I touch the graph more than one time, it's not a function. So this in part B, not a function, because the second vertical line I drew hit the graph twice. Now we can also determine if something is a function or not by taking a look at the equation of the function. So in part C and D we are given an equation, and what we're going to do to determine if these are functions is we're going to use our handy graphing calculator, and we're going to graph them on the calculator to see what the graph looks like, and then use the vertical line test to see if it passes. So you probably don't own your own personal graphing calculator. So for C, y equals 2x minus 7. When we graphed that in class, that was a diagonal line like so. So if I use the vertical line test on this line, there is no point where I'm going to cross this graph more than once. Therefore, y equals 2x minus 7, the graph of a line, is a function. Now for part D, y equals the square root of 2x plus 1. The graph of that gives us like a little curve that shoots off like so. So for this one, when I draw my vertical lines, again, I'm only touching the graph one time because it's got a curve going to it. Nowhere do I have a vertical line happening or the graph below itself again. So y equals square root of 2x plus 1, that is also a function because it's passing the vertical line test. So we're just making sure when we draw a vertical line, we do not cross the graph more than one time. Now in addition to determining if a graph is or is not a function, we also can identify the domain and range of our graphs. So let's read about this next part and then find our domain and range. So you can identify the domain and range of continuous graphs using interval notation. Interval notation includes the use of three special symbols. The first symbol is parentheses. You use parentheses when the endpoints are not included on the graph or the endpoints include infinity. So the only reason endpoints are not included on the graph is if you see an open circle on your graph. However, if there's a closed circle or your endpoint is part of the line, then you're going to use brackets when the endpoints are included. So that's going to be when you have a closed circle. As for infinity, we use infinity when the interval continues forever in a positive direction, and we use negative infinity when the interval continues forever in a negative direction. In other words, when you see arrows on your graph, that's when we'll use infinities for certain things. The arrows tell us the graph goes on forever. So we're going to take a look at 4 different examples here and prove that we can find the domain and range of our graphs. So, use interval notation to identify the domain and range of each graph. So remember from last time, domain is your x values, range is your y values. So what I'm going to do as we go through this, I'm going to outline my graph so I can focus specifically on the x's and the y's. So what I'm going to do, I'm going to kind of shade in so I can see specifically where my graph is. So I'm going to shade the outer parts of it. So I see my graph extends from that endpoint to that endpoint. And the first thing I'm going to do is write down what my domain of the graph is. So your domain are your x values. So your x values are always from left to right. We want to write the leftmost point to the rightmost point. So I was at 1, I ended at 4, and both of my endpoints were closed. That means they were included, so I would use brackets to state this domain. For the range is your y values. So we go from the lowest point of the graph to the highest point on the graph. So my lowest point, I'm down there at -4. My highest point, I was at -1. Again, there's endpoints that were closed, so I'm going to use brackets for this because these numbers are included on the graph. So let's take a look at number 2 next, finding the domain and range of this graph. So again, to make it easier, I usually trace the outside to pinpoint exactly where my graph is. So I'm going to shade in this area where my highest point is, shade in over here where my leftmost part of the graph is, shade in down here. And then this one kind of stops at the graph. But I'm going to shade that in to make it easier to figure out where is my left, right, where is my lowest, highest. So the first thing we're going to do is start with the domain. So domain is your x's, so we need to go how far left does our graph go to how far right does our graph go. So left we were at -3, right we are at 5. So -3 was on the graph, that's going to be a bracket, but at 5 there was an open circle, so that's going to be a parenthesis. The 5 is not included. The next thing I'm going to find is my range. So your range is your lowest point on your graph to your highest point on your graph. So my lowest point is there at -4. My highest point's up here at 3. So at -4 was an open circle, that means parenthesis. And up here at 3 it was a closed circle, that means a bracket. So domain and range, focus left to right, lowest to highest. Write those numbers and pay attention to what type of bracket you should have. So let's move on to doing number 3. We want to find the domain and range of this graph. So again, I'm going to kind of just color in around it. Like so. So that way when I find my domain, I can go straight to the left and say here, and I can go straight to the right and say here. Now, if we take a look on this graph, on the left there's an arrow, meaning my graph's going to keep going, and it's going in the left direction. So whenever there's an arrow, that means infinity, and if it's going left, that's a negative infinity. Same thing on the right, that's an arrow that's going to keep going, so that would be an infinity. And since it's on the right, it's positive infinity. Whenever you use infinities, you put parentheses around them, never hard brackets. As for the range, the lowest point of your graph to the highest point on your graph. So my lowest point is down there at -4. My highest point, I see there's an arrow, so it's going to keep going. So it's going up, that's going to be positive infinity. So a parenthesis for the infinity, -4 was on the graph, so that's a hard bracket. So when there's arrows, that means infinities, and then you just have to make sure you use parentheses for those. And the last example, number 4. We want to find the domain and the range. So again, I'm going to color in so I can see where exactly is this graph. And then find my domain first. So my domain from the left to the right. So on the left, I see there was an open circle at -4. And on the right, there's an arrow. So this is going to keep going. So that would be positive infinity. So parenthesis, -4 was an open circle parenthesis. As for my range, my lowest point to my highest point. Well, my lowest point's an arrow, so it's going to keep going. So going down, that'd be a negative infinity. My highest point was at 3. So infinities always get a parenthesis. 3 was an open circle, so it also gets a parenthesis. So to find the domain and range of a graph, domain, your leftmost to your rightmost value, range, your lowest to your highest value. This concludes our lesson on finding domain and range of a graph and determining if graphs are or are not functions. If you have any questions, please ask Ms. Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Ms. Brooks.